So I'll try and give you guys some background about what's going on here if you haven't figured it out from the email. So this is a class called Statistical Aspects of Data Mining. I'm teaching it at Stanford this summer. Today was the first day at Stanford, just like today is the first day here. Basically, I just had the idea that I'm teaching the course at Stanford anyway. It seems like something that might be of interest to people here at Google. So I work here at Google, and I just teach the class at Stanford. So I thought, well, since I'm going to come to work every day after I teach the class, why don't I just go ahead and teach it here? And so people that are interested can sort of sit here at Google and take the class here. Because of that, sort of the slides and everything you see is basically the exact same as the slides that I'm presenting when I'm at Stanford. So some of the things, like for example, number 4 up here, the fourth thing we did at Stanford today was I took pictures of the students so I could have pictures of them. Obviously, I'm not going to take pictures of you because your pictures are all in MoMA, etc. So there's going to be certain things that obviously don't apply to you, and you just sort of have to be a little bit patient with that. But for the most part, I'm going to follow exactly the script from what I do at Stanford. And to that end, the outline for today is basically to go over the information on the course webpage, run through Chapter 1 on the textbook. I'll talk about the textbook, and then talk about the software that we're going to be using for this class and how you can go about getting it. So unless there's any sort of pressing questions before we begin, I'm going to start going through these slides. Question in the back. Okay, so is that better? Yes. Okay, I'll try and stay close to the microphone. And I'll just try and speak loudly when I walk over to the board. If you can't hear me, let me know.
You have a label mic, maybe.
Yeah, but they said this is just for recording for the video conferencing. So maybe we can figure out how to get that to work over the speaker. Yeah?
Textbook?
Textbook, yes. We'll talk about that right off the bat. Okay, so textbook. Textbook, okay. This is available on Amazon for about 80 bucks. It's called, well, I'll show you on the webpage. It's called Introduction to Data Mining. Authors are Tan, Steinbeck, Kumar. We're trying to order some copies for you guys, but there's no way we're going to have enough. So if you come next time, I may have some to give you via some lottery system, but you can go ahead and order it online if you haven't already. It's a good book to get if you want to just sort of, hope your office mate will order one. You guys can share. But it's a good book to get, and we are going to be following it quite closely, and I'll talk more about it in a second.
Is this first edition or second edition?
There's only one edition, and I've been told there may be a paperback available if you're trying to save money, but there's only one edition as far as I know. Pardon me?
Could you repeat the author names?
Yes, the authors are Tan, Steinbeck, and Kumar, and I'll show you where that's up on the webpage. Okay, so the first thing to talk about is the webpage. It's www.stats202.com. If you ever forget this, if you remember my last name and look up my last name on Google, you'll find my homepage, and then it's linked from my homepage. But basically, stats202.com will have all the information. Now again, this is the information for the students at Stanford, but it will be relevant to you. And so if you just go, let's see, www.stats202.com. And so this is what the web page looks like. Now, some things are not relevant to you. You don't care about the current grades, right? Those are the grades for the students at Stanford. Homework and exam solutions you might care about, right? Because I'm going to give homework assignments. If you want to play along and do them, the solutions then will be up there. Obviously, we're not going to grade them, but there might be, something extra you can do. And then the homework assignments, like I said, they'll be linked from here. If you want to do them, it's up to you, and I will be posting solutions for the student at Stanford. Lecture 1 is linked here. These are just the PowerPoint slides I have, so those will be up there. And then probably the most important thing on the stats202.com webpage is the course information. If you click there, you go to this pink page, and it has, so don't use this email, use my Google email, of course. Also, the email. Let me, in case any of you don't know it, let me write it down. This is data mining, one word, no underscore, 07 at google.com. That's the email I set up. You should have got an email to that already if you signed. I signed up basically everyone on the trick spreadsheet, so you should have got an email to that already. If you're not, it's public. You can go into Mailman and add yourself to that. Phone, that's my cell phone. It's in MoMA. Office hours don't pertain to you. TA, don't bother the TA. Webpage, stats202.com. Okay. Yeah, he would get really confused. Okay, so The textbook we were talking about, there are the authors' names right there, Tan, Steinbeck, Kumar, Introduction to Data Mining. Like I said, I think it retails somewhere between $60 and $80, so go ahead and get yourself a copy of that, or find someone else who's going to have a copy of it and agree to share it. I said we are going to try and get some, but it'll have to be a lottery because there's no way we have enough for everyone that's going to be in the room. Course description. Okay, so this is the Stanford generic catalog description. It says data mining is used to discover patterns and relationships in data. Emphasis is on large complex data sets such as those in very large databases or through web mining. Topics are going to be decision trees. We will talk about neural networks. We'll talk about association rules, which if you're coming from a stats background like I am, that's something new. We will talk about it. Clustering you've seen before, no doubt. Case-based methods and data visualization. And then we're going to basically follow the textbook pretty closely. So first chapter is introduction, just sort of a soft introduction. I'm going to go over that today. Second chapter is on data, basically types of data, importing data, caveats about data. We'll talk about that for about 2 lectures. Chapter 3 is exploring data, and for those of you who know me, I love to make plots of data, and so I think that's very important, even though a lot of people think it's trivial. So we'll spend, I think, at least 3 lectures on Chapter 3 talking about different ways of summarizing data through graphs and tables. And Chapter 6 then, association analysis, basic concepts and algorithms. I have a break right there because that's when the students at Stanford are going to be taking a midterm. If you want, I can email you guys the midterm if you want to sort of quiz yourself. What it might mean practically for us is between chapter 6 and 4, we might have a day where we don't meet, or we might use it as a catch-up if for some reason we don't get through everything, because we are only meeting for an hour, whereas at Stanford they're meeting for an hour and 15 minutes. Chapters 4 and 5 are both on classification. That's sort of one of my favorite areas, so we're going to spend a good amount of time on chapters 4 and 5. And then finally we'll finish with chapter 8, which is the cluster analysis. Evaluation you don't care about either. The late assignments you don't care about. Technology you do care about. So basically we're going to be using R and Excel. Okay, so if you have a PC, that sort of makes your life easy because Excel is probably installed on your PC, and R is of course a free download that's available for PC, it's available for Mac. And there is an R users email list. Maybe I'll send that around to you and with a link for how to install R depending on what your Linux platform is. I don't really keep up with it because I tend to use R more on my Windows machine, but I know that we have installations for Linux and I haven't really kept up with it, so maybe I'll try and send around a pointer to you guys for that. I'll run through today briefly how to install R on Windows, and then maybe from there you can sort of extrapolate and figure out how to install it on Linux. But mainly we're going to be using R with a little bit of Excel, which Excel, for those of you who aren't familiar, is just a real simple spreadsheet application that works well with small data. Academic honesty you don't care about. So that's that's all the information on the web page. So go ahead and use stats202.com as your reference for things in this class. Just remember that the web page is designed for the students at Stanford, so the obvious things don't pertain to you. And for example, right, don't email me at stanford.edu, email me at google.com. I think that's all I wanted to say about the web page. Are there any questions about anything I said so far about the web page? Yes?
This is an undergraduate class?
It's a master's level class, but it's an intro class, and there's a higher level class. There's a 300 class for those of you who are familiar with the Stanford curriculum. So it sort of necessarily keeps this at an intro level. Which I think is good for us because a lot of us are sort of, this is our first time seeing some of this stuff. If this isn't your first time seeing some of this stuff, that might, you might think, well, this might be too basic for me. So sort of pick and choose when you come or what lectures you watch. The lectures are being videotaped. They are available on Fish. So those of you who don't want to sit here, would rather just sit on your PC and watch it there, sit on your machine and watch it there, then, they are going to be up on Fish. Any other questions about anything I said so far? Okay, so moving on. So the textbook, again, we'll start with chapter 1. It's just a real soft introduction to what we're going to be doing in this class. But it is sort of interesting. When I said I was going to teach this class on data mining, the first thing my office mate asked me, he said, well, what is data mining? I said, well, I'll be able to tell you that by the time I'm done teaching the class. Well, hopefully, by the end of today, we'll be able to say something intelligent about what is data mining. So the definition in your textbook, it says, the process of automatically discovering useful information in large data repositories. and there's many other definitions. So let me just sort of dissect this a little bit and sort of, I come from stats. The question is, how is data mining different from statistics? Well, I think the easiest one, right, is the notion of large, right? The fact that the data set is large. So one way you could define data mining as well, it's statistics with large data sets. Okay, but there's more than that, right? There's this idea that I'm automatically discovering useful information. Again, what does automatically mean? Well, you're not going to write a script that's going to do all the analysis for you and tell you, hey, I looked at your data and, you should be aware that, there's some problem with this variable or there's something strange going on here, right? It's not going to be completely automatic, but it's sort of more automatic than statistics, right? So in statistics, you might say, you know what, I really want to analyze these two variables and see, what the correlation is between them, blah, blah, blah. In data mining, you might say, look, I have 1,000 predictors in this data set. I want to look at all pairwise correlations, and I want to get an automatic email every time two of those correlations goes above a certain value, for example. So on some level, it's more automated and than stats, but of course, it's not like a magic thing that does all the work for you. And then the final aspect I was just going to mention is discovering useful information, right? I mean, obviously, there's a lot of data out there, and the goal of data mining is to see if there's anything useful there. And actually, one last aspect of this definition I want to mention is the last part where it says the data is in large data repositories, right? So it doesn't just say large data sets, it says large data repositories. So you think of a repository as someplace where data just accumulates, right? You didn't necessarily collect it, it's just there, right? So weblogs are an example, right? I mean, the data is just there. Whether or not you're going to get any use out of it is up to you. Like a whole bunch of other examples we'll have, credit card transactions, supermarket data. The data isn't really being collected for any specific reason, but it's sort of hard to not collect it. The data just sort of accumulates naturally. So the question is, given all this data is there, can we find any useful information in it? And that's quite different from statistics, where in statistics you often say, you know what, I'm going to go out and collect data specifically to answer a specific question. Whereas in data mining, you're accumulating the data, and the question is, can I find anything useful in this data? Okay, so then I say there are many other definitions, and on the next slide I say, so find a different definition and see how it compares to the previous slide. So this is sort of a fun exercise to sort of look through and see what other people say is data mining. And the first thing that you'll notice is that, the authority, right, Wikipedia, it doesn't give one definition, it gives two, which already suggests to you that there's some, non-uniform standard for what is data mining. So the first definition is non-trivial extraction of implicit, previously unknown, and potentially useful information from data. And the other is the science of extracting useful information from large data sets or databases. So that second definition, which I think that's a stat reference, right? Yeah, David Hand. So that's very similar to what we had. The idea is that you're looking to see if there's anything useful, the data set is large, and basically it's the art or the science of extracting that. The first definition isn't too different. It just says potentially useful information from the data, a little bit of an admission that sometimes we're not going to find anything useful. It does say here, the first one, non-trivial, and I'll talk about that in a second. There's a lot of tasks that you could say, look, I'm extracting useful information from data in an automated way, but it's sort of trivial, right? So data mining deals with what we'll call non-trivial, and I'll give you some examples in a second of what I would consider trivial and non-trivial, and your textbook talks about those. Other definitions, so you can sort of see, I think there's a few I clicked on earlier. What is data mining? It says here, generally data mining, sometimes called data or knowledge discovery, is the process of analyzing data from different perspectives and summarizing it into useful information. Sort of not that good of a definition. I think this one was pretty close to what we were talking about. Let's see, there's a what is data mining somewhere down here. Yeah. Data mining or knowledge discovery is the computer-assisted process of digging through and analyzing enormous sets of data and then extracting the meaning of the data. So you see the digging through is sort of carrying on the mining analogy. There are a couple more. Maybe I'll show you one more of these that I thought was pretty good. What does this one say? Data mining is what? Analytic process designed to explore data, usually large amounts of data, typically business or market related, in search of consistent patterns and or systematic relationships between variables. I think this little parenthetic statement, typically business or market related, is telling. I mean, we're looking at it from a point of view of, most of us are computer scientists, and so we're looking at it from more of a science point of view, but it's really things in industry and and the market that has driven data mining. That's really where the phrase comes from. And it's sort of one of these, catchy, trendy words that like, oh, that company, my competitor is doing data mining and I'm not, so they're going to beat me. So that's, that's where a lot of it comes from. If you're cynical, it really is just, well, it's statistical techniques or it's machine learning techniques or it's, these techniques with a new word put on them. But, it's sort of, that's how things in business and market get popularity. Someone attaches a word to them. And so this is basically the word that's been attached to, again, as your textbook says, process of automatically discovering useful information in large data repositories. Now, I'll say as an aside, so, like I said, I come from statistics, and my office mate has the same background as me, and he said, all you really have here is two ingredients, to make a disaster, right? You have a lot of data, and you don't know what you're looking for. He said, you're only going to get yourself in trouble. Well, you can and you cannot. So we'll talk about some caveats that you have to be careful about. But generally, this is the feel of it. You have a large data set, and you're just looking to see if you can find some useful information in there. And what he warns about getting yourself in trouble is you need to make sure it really is useful, and you're not just telling yourself some story that's completely artificial. So I mentioned to you, some data mining tasks aren't really data mining tasks, right? Sometimes you think you're extracting useful information from a large data repository, but it's not really considered data mining. And that's because it's too trivial, right? So here on the left side of the screen, you have some data mining tasks. On the right, you have some non-examples, right? So for example, looking up a phone number in a phone directory. Well, that's extracting useful information. If you want the phone number, it's useful to you. The phone directory is a large data set, so you're extracting useful information from a large data set, but it's not considered data mining. It's too trivial, right? An example of something that would be data mining would be, suppose you have the phone book and you start to look for relationships that you previously didn't know. So for example, it says here you see names like O'Brien, O'Rourke, O'Reilly occurring more in the Boston area. And you say, oh, well, I didn't really know that, but it makes sense to me now because I sort of know how the different people settle in the United States, and I know there's a lot of people, of certain descent in this area, so it makes sense to me. And if you say, well, that's, I knew that already, imagine, giving it the phone book from India or from, Brazil or a country you're not familiar with, and you don't know any of these names, and you start to see how they cluster in the different regions, you're learning something about the data without really knowing what you're looking for going in. You start to see this grouping. So that would be an example of data mining. On the right here, the second one, query a web search engine for information about Amazon. Okay, I'm getting useful information from a large data set, right? The web is a large data set. But again, that's not data mining. Something that would be data mining here on the left, group together similar documents returned to a search engine according to their context. For example, if you thought about drawing a picture of all the web pages that come back for the query Amazon, and sorry if you can't hear me, you start to see two groups, right? You start to see here's a group over here, and here's a group over here. Okay, and you say, how are these groups, right? Well, maybe, users that query Amazon go to these pages or they go to these pages, but there's very few users who query Amazon that go to a page here and a page here, right? So these are connected and these are connected, but they're very split. So what have you learned? Well, you've learned that maybe Amazon has two different dominant interpretations. So presumably one is the retail site and the other one is the river. And you say, well, I knew that already. Hang on a second. I knew that already. But imagine doing it in a language that you didn't know already, or imagine having some automated process that would tell you when a query has two dominant interpretations or when it only has one main interpretation. What was your question?
Oh, just when you add on the board, if you have a black marker, it would be easier.
Yeah, if someone can toss me one, I don't really have it.
There's one right on the podium.
Where? Oh. See, I have to search for it. Okay. Okay, not data mining. All right. So imagine those are black. Okay, so that would be an example of data mining, and that's actually clustering, and we'll talk about that specifically as an example of clustering. Okay, so why mine data? So just the scientific point of view. Now I'm going to talk about the scientific point of view and the commercial point of view. Both of these basically have this flavor like I'm collecting the data anyway, so there might be some useful information in it. And from a scientific point of view, you're collecting lots of data. Examples would be a satellite that has sensors on it, telescopes that look across the sky, microarrays, with gene expression data was sort of trendy a few years back. Generally, any simulation you do, you can generate lots and lots of data. I don't need to tell, you guys about collecting lots of data. Traditional techniques are infeasible, and so data mining might be helpful in sort of classifying and segmenting data or informing hypotheses. So that's sort of the scientific point of view. The commercial point of view, again, the commercial point of view is really sort of driving the data mining on some level. Data there is being collected from web data, from e-commerce, right? Anytime you use a search engine, I don't have to tell you, anytime you buy something from a site online, anytime you go to the department or a grocery store, anytime you use a bank or a credit card. So the data is just there. Computers are cheap, right? You can't say, oh, we can't afford to store that much data. No, storage is cheap. Oh, we can't afford, to analyze data. No, the, processing is cheap. And then your competitor is doing it, right? If you don't want to do data mining, well, you can be certain that your competitor is, and if it's giving them any edge, well, you're going to get beat out eventually. Now, the one thing I wanted to talk about on this slide, which I always thought was interesting, the grocery store example is sort of it's like the classic defining example of data mining, which is that when you go to the grocery store, they have a record of, you bought eggs and you also bought diapers, or you bought milk and you also bought beer, you bought chips and you also bought salt, so they have a record of that. Now, the funny thing is, you should think about is how do they have a record of that, right? So if I go to the grocery store today and I buy chips and I pay cash, right? Suppose I pay cash, don't use my credit card. I'm trying to sort of be off the grid, right? So I pay cash and I get the chips. Then tomorrow I go and, I forgot the salsa. So tomorrow I go and I buy salsa and I pay cash again. What they don't want to know just that one person bought chips yesterday and one person bought salsa today. They want to know that it's me. They don't just want to know what I bought. They want to know who I am. So the question I'll ask you is, how do they know who I am if I don't pay with my credit card? Yeah, you have the little, your Safeway, save 6 cents on gas, right? They have your little Safeway card. So you can think about it, that sure, they don't get the data for free, but all they have to do is give you a little card and let you save 3 cents on every purchase or whatever it is, and now they get all the data in the world, right? And you can opt in or opt out. You don't have to use the card. If you really want to, don't want people spying on you, you can just not use the card, but it's not hard for them to get the data, and once they do something like that, they have the data. So that type of supermarket data where they know each customer, at least their ID, and what they bought is sort of one of the classic examples of data mining data sets, where they use that data to discover relationships between, people who buy this product usually buy this product. Now, what does that mean for the grocery store? Well, use your imagination. If they often buy these two products at the same time, maybe they should put them in the same aisle. Better yet, maybe they can say, look, let's close down the whole supermarket and just sell these two products because we know, if we just stock those, we can make this much money, things like that. So anyway, they have that data because they give you your little discount card. And they give you the discount card for other reasons too. So this is sort of a fun exercise. I knew I was going to give this one today, so I started thinking about it as soon as I woke up. So I'll give you 4 examples. It says here, give an example of something you did yesterday or today which resulted in data which could potentially be mined to discover useful information. Okay, so in black, I will write here the 4 things that I thought of and see if I can get you guys to give me some others that I haven't thought of. So I just literally went from the time I woke up. Actually, I went from the time I woke up to the time that I started teaching and came up with some examples. So the first thing when I wake up, the door on my apartment doesn't have a key lock. It has this card, right? A little card, and it goes beep when you open it. So you think, well, they're not going to keep that data, right? What do they want? Why would they want to know that data? Why would they want to spy on you that much? Well, actually, when I moved in, they told me, they said, don't use your card to try and open someone else's apartment door because we'll come after you. We'll get mad at you. And I thought right away, that's kind of weird, right? I mean, what if I just take the elevator to the wrong floor and, I'm half awake, right? But, presumably they're keeping that data around, or at least they have some sort of alert system. So you wouldn't think it, but, I'll call that my apartment door. Presumably that data is sitting around somewhere where they know what tenants try to open what doors at what time. And if there's any useful information there, they can use it. What would you use that information for? I don't know. Maybe they want to hire a security guard and they want to know what sort of traffic, whether people are coming and going. Maybe they do really want to spy on you. I mean, they can use the data for whatever they want, right? And you're consenting to it because you're the one, using the card to open and shut your door. You're the one living in their apartment. Okay, so then after I open the door, what do? Well, I go and I hit the elevator button. Now, that one I'm not really sure if they're keeping that data around. But I kind of, I wish they would, because maybe if they had some intelligent system, I wouldn't have to wait so long for the elevator, because, what's it doing down there on the basement when everyone's sleeping? They know that, it should be sitting up at the top. Okay, after I go in the elevator, then the parking garage has another thing, but that's the same as the apartment door. As soon as I get on Guadalupe Expressway, there's metering lights. And I wish that they would use the traffic sensors, to do something better about the traffic, right? So presumably they could know that they don't need to turn the metering lights on at 87 when 101 is moving so quickly. So, they could mine that data too. They know who's driving on the highway. Well, they don't know who's driving. They know how many cars are driving on the highway at what time. They don't really know who you are, although if you had like the fast track and went over the bridge, they would know who you are, right? Because it's your fast track. And then finally, when I get to Stanford, they don't give me like a nice parking pass, so I have to put money in the pay parking machine. And how do they know who I am? I use my credit card, and I use the same credit card every time. So these are, none of these are related to internet applications. I'm trying to, be a little bit creative. All cases where I'm producing data that someone could be using to do data mining. And they're not trying to spy on me. It's just I'm giving them the data. It's freely available for them to use for whatever purpose they want. So this is what in-class exercise number 2, I called it. So I gave you 4. How about you guys give me 4? Yeah, Charles.
Completed stuff in a micro kitchen.
The micro kitchen. And then they run out of data, right? So they have to restock the micro kitchen. They run out, so they know what we're eating and what building we live in, right? Okay, so that's, yeah. So presumably someone's looking at this data in the micro kitchen. Okay, one more in green.
Yeah,
Sorry.
The government's tracking wherever you go from your cell phone.
Cell phone, right? Not only, right? Yeah, so you can turn that off, right? But not only do they know who you are, who you called, what time you called, they also now know where you are because they have that little, GPS location sensor in there. And, I don't know, if you're a paranoid person, this isn't a good exercise for you, but, the data's there. They could ignore it if they want, but it's there, and they might find information in it. Okay, another one in the front.
Google badge accessible.
My badge, right? So someone actually asked me this one time, so let me just say this is my badge, right, which is, B-A-D-G-E, which is similar to my apartment door, but this is, an employer, right, who might have a little more interest in who I am and where I'm going at what time. And when people ask me, I don't know if they ask you this, when you tell me you work at Google, they say, well, what time do you start work? And you say, well, it depends what time I wake up and things like that. And they say, well, what time does your boss tell you have to be there? Well, whatever. And then they say, but certainly, they know when you scan your badge in, and they keep track of that. And I go, well, I guess they could, right? But, knowing Google, they're likely to use that data, but not, to spy on us, more so to sort of just keep statistics and to know when they should stock the micro kitchens, right? Or know when they should serve breakfast. Okay, so let's get one more. Yeah.
Yeah, so when you use your laptop, we know
Yep.
where you are and
Yep.
how often you use it,
Yep.
how
So
much data you're transferring.
laptop. Yeah. One time, that doesn't say P. Laptop. One time I was using a computer somewhere in an office at a university, and the guy called me and he said, "Why are you VPN? Why are you using a VPN connection?" And I thought, who are you to ask me why am I using? But he was the administrator of the network, right? So. Yes, anytime you use a computer, people are getting lots of information about you. And we have weblogs here at Google. Stats202.com, we have weblogs from that. So one of the things we're going to be doing is playing with the logs for that. And it'll be cute because we can see certain spikes when certain events happened, and I can see what web page you go to. I don't know who you are, but I know your IP address. So anyway, you can think of loads of examples here of different cases where you're producing data that if someone wants to, they can mine, they can use it to get information about and help them to make different decisions. Okay, so where does data mining come from? So, you can tell this book is sort of a statistical book because you see statistics and then you see everything else. What's everything else? Well, you have artificial intelligence, you have machine learning, you have pattern recognition, and some people sort of put databases and things like that and information retrieval there too. But You know, it is sort of like I'm teaching this course from a statistics point of view, but it's not just statistics, of course. It's borrowing ideas from artificial intelligence, machine learning, pattern recognition, and all those. Traditional techniques, when we say that traditional techniques in the second bullet, it's traditional statistical techniques would be unsuitable. Why? The data is large, not just large like a lot of observations, but large, it's high dimensional, and heterogeneous and distributed, right? So there's sort of new challenges for statistics. We coined this phrase data mining, but we're borrowing information from, or we're borrowing ideas from all these other areas too. Okay, so the book breaks down into two types of data mining tasks. And this dichotomy is a little bit forced in some cases, but I'll walk through it. So they differentiate between predictive methods and descriptive methods. And let me sort of write the shorthand version of these. The one thing to remember is, I guess, descriptive methods don't really have one right answer. You sort of know if you found something useful because it's useful, but you never really know exactly what you're going after. Whereas predictive methods, you're going to look at your classification accuracy or your precision and your recall. So those are straightforward. So predictive methods, this is predictive. What do we have here? It says some variables to predict unknown or future values of other variables, right? So basically we're trying to predict future in some sense, right? We're trying to use some inputs to predict the future classification of some output. Whereas descriptive methods, for that, we're just basically trying to find patterns in the data. Okay, find patterns. Okay, so you know the way to remember this, right, is sort of this is the supervised learning and the unsupervised learning, if you will, right? So the example I would give you, if you think about the Amazon, right? With Amazon, I found a pattern, right? There were two distinct types of pages about Amazon. There was like the commercial Amazon and there was the river Amazon. So I found the pattern. Okay, suppose alternatively that so that would be descriptive. I described a pattern. I described that there were two groups of the Amazon web pages. Predictive would be more like, I know that there's two types of Amazon web pages. I know there's the ones about the commercial site, and I know there's ones about the river. Okay, I know that there's two groups. But can I predict, given a new one, given a new web page, right? Can I have a computer algorithm that will predict which one of these two classes it falls in? And the way I'm going to measure success there is how accurately am I going to be able to predict this, right? What is my misclassification rate? Am I going to get 90% of them correct, 95% of them correct, et cetera? Now, it's real easy for a human to read the web page and say, oh, this is about, you know, Amazon the retailer, or this is about Amazon the rainforest. But, you know, can a computer use the human-labeled observations to get a pretty accurate rule? That's predictive data mining, whereas, again, I told you descriptive data mining was just finding the fact that there's two groups in the first place. So the topics that we're going to cover fall into these two categories as follows. So the book talks about classification and regression as both being predictive. So let me make this. So we'll put here classification and regression. Both of these as being predictive. Now, classification we're going to cover in chapters 4 and 5. Regression we're not going to cover in this course. However, if you take a stats course, they're going to cover regression. Really, the main difference between these is classification, you're trying to say, you know, I said I'm 90% accurate, right? I have two classes. It's either Amazon the rainforest or Amazon the river, right? Or you could have 3 classes or 4 classes or any number of classes, and you're trying to see how accurate you are. Regression is analogous to that, but instead of trying to predict a class, you're generally trying to predict a continuous attribute, right? So let me give you an example, right? So to change from a web application. This is a book, this is an eraser. You can tell these apart, right? Suppose you send like sonar signals, right, and bounce the sonar signals off the book and the sonar signals off the eraser. Well, they're going to look different, right? And so classification would be to use those sonar signals and some labeled instances of the book, some labeled instances of the eraser, and predict for new cases whether it's a book or an eraser, right? That's classification. I'm trying to predict, is it the book class or is it the eraser class? Right? Just like, is it the Amazon rainforest class or the Amazon commercial class? Regression would be more like, can I use the sonar to predict the size of the book, right? So you don't just either get it right or wrong. If you say the book is 11 inches tall and it's really 10.5 inches tall, you're off by exactly 0.5. So classification, you're basically trying to predict what class it is, whereas regression, you're trying to predict some continuous attribute. And so you would measure your performance a little bit differently. Classification, you might use recall, precision, or misclassification rate. Regression, you might use like squared error loss, L1 loss, some sort of loss function like that that measures how close you are to the target. We're not going to cover regression. Classification is more common in data mining, but regression gets a lot of attention in classical stats courses, and also a lot of the classification techniques you can extend to regression. We're just not going to get into them. Okay, then for descriptive, visualization we're going to cover in Chapter 3, association analysis in 6, clustering in 8, and anomaly detection is in Chapter 10, although we're not going to get to it. So let me just say a few words about these. So visualization is in Chapter 3. Visualization, as I said before, it's one of the most important things you're going to do. If you think about writing a report or doing some study, people are going to remember the picture, right? If you can't tell it with one simple picture, you probably haven't really said anything interesting. And there's sort of an art in making good pictures and making pictures that people can see clearly. And so we're going to spend a fair amount of time in Chapter 3 just talking about different ways to visualize data. And visualization can be two purposes, right? One is to present to someone. Okay, you know what you want to say, and this is just a good way to present it. And the other is to learn something yourself. You don't know what you're looking for, but you're just going to look at a bunch of pictures, or you're going to look at one picture that's going to tell you what's going on so you can discover it. Both of those are visualization tasks. They're both descriptive, and we'll talk about those in Chapter 3. Association analysis. Association analysis. This is something that doesn't really make it into mainstream stats too much. We're going to talk about that in Chapter 6. This one is the classic supermarket one, right? The people that bought diapers often bought beer, right? The people that bought chips often bought salsa. This is the type of association analysis, and we're going to talk about that in Chapter 6, in particular that market basket example I just talked about. Clustering, Chapter 8. Clustering. Okay, the clustering example, the canonical example there would be like the Amazon search engine versus the Amazon rainforest, right? You see two distinct groups emerge, you know something's going on. And of course that example is trivial, but suppose I give you a query in a language you don't know. Can you tell me, what sort of pattern there are in those web pages? Are there two main interpretations? Is there one dominant interpretation and one slightly less common interpretation? So you're just sort of looking for patterns in the data, and grouping is one pattern, and that type of grouping is called clustering. News stories, right? Can you group together different news stories? These are about sports, these are about politics. Can you see different groups emerging in the data, even without having labels on them? So it's unsupervised, it's clustering. And then finally, anomaly detection, we're not going to have time to get to, but you might want to read about it in only 1L, right? You might want to read about it in Chapter 10. When we do Chapter 3, we'll do some of it. Because when we make pictures of data, sometimes that's exactly what we're looking for, things that are strange. Anomaly detection is probably, as I say, association analysis is one of the classic examples of data mining. Anomaly detection is one of the ones that gets all the press because, shoot, I had a news story. I don't know if I can find it. That, you always see data mining in the news because they're using it for purposes of credit card fraud detection, and they're using it to find terrorists, right? And both of these things are anomalies, right? So what is a credit card fraud, right? Someone, you have your credit card and all of a sudden you spent a whole bunch of money in a place that you've never been before. That's an anomaly. The credit card flags it. The sooner they can flag it, the more money they can save. So that's anomaly detection with respect to credit cards. With respect to terrorists, what are they looking for? Strange behavior, right? Something that's indicative of a terrorist. Now you could argue, well, in that case, maybe this should be up here because you're trying to see how accurately you can, spot the terrorists. But, that's why I said this line is a little bit blurry, but your textbook tends to classify anomaly detection as descriptive because you don't really know exactly what you're looking for. Okay, that's all the Chapter 1 notes I want to talk about. Now I'm going to talk a little bit about the software, but let me stop and see if there's questions. Question?
So we end up giving yet more data to the data mining wheel, because every time we're planning a trip, we have to inform every credit card company that we will be spending stuff abroad.
Right, yeah, so
really
the question is, if you don't want your credit card to sort of, call you and cancel your card because they see something weird, some people will call the credit card company ahead of time and tell them, look, I'm going to be traveling overseas. But then the point is that they can also use that data to, feed into the data mining framework. Yeah, some people will do that. Some people, every time they're going to travel, they'll let their credit card company know ahead of time because they don't want any problems. I actually have a friend who's a pilot who uses cash only, which is surprising in this day and age, but for that very reason, he doesn't want to call the credit card company every time he goes somewhere. And he does flights that look as though they're anomalies, right? So anyway, any other questions on anything I said so far before I talk about software? Question.
So what is the difference between clustering and classification?
Okay, so your question is, what's the difference between clustering and classification? Okay, so they're very similar. Clustering is unsupervised. Classification is supervised. So the thing is, let's go with the web page example, right? With the Amazon, right? In one case, I have all the two instances labeled. This one is about the rainforest. This one is about the e-commerce company. And I'm trying to predict for a new observation which one it is. And I'm going to measure how accurately I'm doing. That's classification. That's predictive. I want to see how well I can predict a new observation into these two classes. Okay. Clustering, on the other hand, is the act of actually discovering that there are two classes, because I didn't know that ahead of time. I was just looking at a bunch of different queries, looking at how things group together, and I saw two distinct groups emerge for Amazon. Now, the clustering is, you don't really know you're right. Are there really two groups? Well, in this case, you do, but you're just sort of trying to discover a relationship. So is that good? Is there anyone else that can give a better definition than I just gave? Because a lot of people in this room are experts on machine learning, and they can tell you supervised learning, unsupervised learning, but that's sort of my take on it. It can be a little bit blurry, especially after you do the clustering. If you say, "Oh, I really did learn something that was right," that it tends to have a little bit of the classification feel, but that should help. Okay, other questions? Yes.
Is anomaly detection the same as outlier detection?
Yes, to a large degree. And there's some subtle differences, and you can read about that. But yeah, generally an anomaly is an outlier and vice versa, generally speaking. Yeah. An outlier, you can sort of see the word outlier, something that lies out away from the rest of the data is an outlier. So in some space, an anomaly is an outlier, but the key might be to find that space. Other questions about things that I've said so far?
Yeah, is an anomaly like an unsupervised version of an outlier predicted, and the actual values for a difference in the anomaly, and have a response? Like you're doing clustering, and it's just one guy who doesn't really want to be clustered.
Right. So Charles was making a point about the relationship between outliers and anomalies. I don't want to get too much into that distinction, but yeah, there's a relationship and some subtle differences. Other questions on what I said, anything I've said so far? Okay, so let me see. How are we doing here? So, okay, we're doing good on time. So, like I said, Stanford, this is an hour and 15 minutes, but here we're trying to stay under an hour, obviously. So I go a little bit faster and skip a few things that don't matter for you guys. Okay, so what are we using in here? We're using Excel and we're using R. Now, Excel, if you have a PC, you're in good shape. If you don't, I don't know, Tricks probably won't give you everything you need. No offense, but it's just not the same product. OpenOffice might give you everything you need, but if you have a PC, you're in good shape. If you have a Mac, I'm sure Excel is installed on there. If you don't have either of these, if you're sort of just a strict Linux user, I don't know. I can't really speak to OpenOffice, but it might get you through most of it. But we are going to be using Excel, not primarily, right? Excel isn't very powerful. It doesn't handle large data. It's very slow. But for some purposes, it's good, and it is good to sort of have a spreadsheet application, sort of that you're comfortable with, because sometimes you can do things very quickly that you don't really want to take the time to script up. So we'll be doing some things in Excel. And so you should have access to that. But then primarily we're going to be using R, which is free. If you have Windows, I'll go through how to install it on a Windows machine right now. The same installation instructions will generally hold for the Mac. And for Linux, like I said, I'm going to try and send you guys a link to something on the something I can get from the R users, which talks about installation. But different people do different installations depending on what they're doing, and so I haven't really kept up with it. But let me take you through R and give you a little preview of that and show you how to get it installed on your Windows machine. I have a Windows machine right here, obviously, so as I go through examples, I'll be doing it on the Windows machine. So, you know, you might, if you have a Windows laptop, just install R on that and use that for going through examples. Also, it's easy, you can bring it with you and you can sort of play along as you're sitting here. Okay, so how do I download R? So you go to this web page, right? It's sort of a little bit tricky. For a while on Google, if you just queried R, you wouldn't get it. I think you can now, but let's just go to CRAN. Let's see. There we go. Okay, so we're going to be good with, I have a Windows machine, so I just hit Windows 95 or later. And then base. So it's open source, and different people contribute different packages. If we need anything special, I'll let you know, but for now, base is going to do the trick. And then if I go down to this one here, this is a self-extracting exe file. It says I have to get it from a mirror near me, but it turns out if I click on this, right now the behavior is it's just going to give me one, and I can just save it. Then you double-click, go through all the defaults, let everything as it is going to be fine, and it will get you R. And once you do all that, you can see what it looks like. Here, let me just run through those screenshots again. So these are up on the PowerPoint slides if you sort of forget what I said. So go to cran.rproject.org, and for me, I would click on Windows 95 and later. Just click here on base, and then 2.5.0. I think I have a 2.4 version. The version shouldn't matter too much if it's within the last year. You save this to your machine, and then it will just install itself, and all the defaults are pretty good. Once you do that, okay, you get something that looks like this. So here I have actually 2.4.1 on my machine. And it's sort of command line, right? It's not a spreadsheet app, it's sort of command line. Let me see if I can make this a little bit bigger for you so you can see. Let's change the font size from 10 to, let's try 20. That's too big probably, right? Looks like a cartoon. Okay. So, it's sort of command line, right? I can do 10 plus 1 and figure out that that's 11, okay? You have functions in here, right? So let's see. Let's think about an easy function. exp is exponential. E to the 0 is 1. Okay, so you have functions. You can look for help on the function. So I want to help on the exp function. If I type question mark in any function, it brings up a window and tells me, that this is log computes natural logarithms, log 10 computes, okay, and it gives you some examples. So the help is pretty good. And you can look things up online because there's a lot of documentation. So it sort of has command line. You can write your own functions. You can, sort of use it as a little bit of a scripting language. But also it's really good for plotting, right? So if you type okay, well, sequence 1, 10 is the integers 1 through 10. So if I made a plot of, well, here I'll just show you. So let x be the sequence 1 through 10. And if I plot, suppose x, comma, let's say x plus 10, then I get a plot, right? And you get to change sort of almost everything you can change on this plot. You can change the plotting symbol, you can change the font, you can change the color, you can make it clickable, you can label things. So the plotting in R is really good, and it gives you a nice tool for making plots very quickly, and we'll go through a lot of that when we get through Chapter 3. But I think in the meantime, go ahead and make sure that you have a machine where you can use R and get it working. And next time when I get into Chapter 2, I'm going to go through some example data sets, and we'll talk about manipulating them in R and Excel a little bit. But let me just take the last minute here and see if there's sort of any questions. So I'll just run through in case you missed at the beginning. The whole point here is that this class, I'm teaching it at Stanford, so it's not too much extra effort for me to come here and teach it here. It is being videotaped, so you can watch all these, on your machine at your desk. It's an hour, even though the Stanford class is an hour 15 minutes. And you can sign up on Mailman. You're welcome to come to any lectures you want. Everyone's invited. This is the textbook. We'll try and distribute some of these next time, but there won't be enough. We'll have to do by lottery, so go ahead and buy one. Go to www.stats202.com for all the information about the course, and make sure you're subscribed to the data mining 07 at google.com. And so I think that's all the organizational information. We're going to meet Tuesdays and Fridays from 1 to 2. I can't think of anything else that I might have said. Let me just stop and ask if there's any organization questions or anything. Yeah, question?
Can you get a larger room?
No, actually. I mean, I asked about this, and they said, like, well, you can, but you have to go through another process. So this is the biggest room the Google EDU folks had, and so...
The machine learning EDU talks had a lot of attrition. Like
Yeah.
From the first lecture to
So we hope that a lot of you have information. We hope that...
Why are you looking at me when you say that?
Because you're sitting on the floor. I can talk to the Google EDU folks about that. I mean, they've been extremely helpful. It was sort of a challenge to estimate the attendance, and we knew the tricks was an overestimate, and we didn't know with the video conferencing how many people would actually want to come. And I think I still don't know how many people actually want to come, right? I think we'll know more on Friday. I think if we're still overflowing on Friday, then you can really try and see if we can do something better than having people sit on the floor. Other organizational questions? No other organizational questions? Okay, hey, there's free lunch in the cafeteria.